Seventh honors class, we're looking at section 7.4. This is about three-dimensional figures. I want to introduce this and have you guys do a few problems over the weekend so we can get past this a little bit more quickly. We are running behind, so I want to make sure that we take care of business. Three-dimensional figures are called solids. They're also called polyhedrons. So a polygon is a two-dimensional figure, a shape, basically a triangle or circle. Not a circle, but a triangle, square, trapezoid, these sorts of things. Polyhedrons are same idea but with three dimensions. So something like this is called a rectangular prism. Almost looks like a cube, except it's not a perfect square on each face. This is a rectangular prism. Let's look over all these things that mean. An edge is just a line in the shape. So DC is an edge, HG is an edge, FG is an edge. Those are all different edges. Parallel lines are two lines that are in the same plane but do not intersect. So you could think of this top of this box as a plane. It's a flat surface. You call it plane ABC if you want. A plane is defined by any 3 points in that plane. So you can say plane ABC. But you could say line AD and line BC are both parallel lines in that plane. They never intersect. Skew lines also don't intersect, but with one major difference from parallel lines. They're not in the same plane. So skew lines would be like AB and EH, because AB is going all the way out this way, and then EH is going this way, but below it. So even though it looks like they might cross here, they don't, because AB is above it, almost like a freeway overpass, or a bridge. It looks like they would crash if they were in the same dimension, but AB is over it, so AB just crosses over EH. Those are skew lines. They don't intersect, and they are not parallel because they're in different planes. A face is just any of the outside square or rectangular looking things in this shape. So this face, CDHG, that's a face, and a face is always going to be a plane. But there are 6 faces on this rectangular prism, top and bottom, and then 4 sides. Vertex, there's 8 vertices here. A is a vertex, B is a vertex, C is a vertex, D is a vertex, E, F, G, and H are also vertices. This here is a prism. The definition they use for a prism is a polyhedron with 2 parallel congruent faces, which are called bases. So a prism is something that has 2 congruent bases. So you can even think of this as a prism. This would be called a triangular prism because it has, oh sorry, I drew that poorly, but if you have a triangle on the top and the bottom, they're parallel and they're congruent, and then you have a middle part, but this would be called a triangular prism. Let me do a better job of drawing it here. It'd be like this, then like this, and then this connects here, and this connects here, and this connects here. Still kind of a poor drawing, but this is a rectangular, a triangular prism. Like a ramp would be a good real life triangular prism. Let's see what else we got. Let's go over some of this other stuff. So bases are the 2 parallel congruent parts of the prism. So you can't say one of these side things is a base in this sort of thing. In a rectangular prism, you can basically call any opposite sides bases. In a triangular prism, you basically have to choose the triangles. A pyramid is slightly different. A pyramid has only one base, and it can be either rectangular, square. It can even be a hexagon or a pentagon. It can be any shape on the bottom. This is looks like a square pyramid. It has one base, and then that's it. A cylinder, a cone is very similar to a pyramid, except it has a circular base. Also, a cylinder is very similar, and that's why I drew these lines. A cylinder is very similar to a prism, except it has circular bases instead of either triangles or squares or rectangles or something like that. So you can think of prisms and cylinders going together, and pyramids and cones going together. Let's see what else we got here. Not too much. I want you to do some homework on this. I'm going to write these. It shouldn't take you very long. and it'll really help us kind of jump to the next thing in class. I would like you to do numbers 1 through 14 on page 370 and 371. It might overlap some of the other homework I gave you, and it's good. You'll get it done. You won't have to do it later. But this is your homework for the weekend. 1 for 14, along with the stuff that we worked on in class today, which some of you may have finished. So work on this page 370, 1 through 14, all of them, and we'll go over them on Monday. Do your best on these though, and see if you can figure them all out.